Welcome to This Explainer. Today, we're digging into a literal cosmic recipe, the 4.6 billion year history of planet Earth.
Okay, let's dive right into this. When you look around at the trees, the oceans, all the crazy diversity of life we have today, it's honestly kind of mind-boggling to think that about 4 billion years ago, this very planet was a deadly, boiling ball of lava. Literally a sea of molten rock. So how in the world did we get from that to this beautiful blue oasis? Well, to figure that out, we've got to rewind the clock, way, way back.
So, anchor yourself right here. 4.6 billion years ago. At this point, our solar system, it doesn't even exist yet. No sun, no Earth, no nothing. Just deep, quiet, and incredibly dark space. But actually, it wasn't completely empty.
Floating out there in the dark was our very first ingredient, the solar nebula. Think of it as a massive, quiet cloud made up mostly of hydrogen and helium gas and dust. And for millions of years, it just sort of drifted there. Nothing much was happening. But, as we know in the universe, calm never lasts forever.
Suddenly, bam, that piece is completely shattered. A nearby dying star exploded in this massive supernova. The shockwave from that blast ripped through space, slammed into our quiet little nebula, and caused a massive gravitational collapse. It basically flattened the cloud out into this spinning shape we call a protoplanetary disk. And as the center of that disk squeezed tighter and tighter, the pressure and temperature went off the charts, up to 15 million degrees Celsius. That insane pressure triggered nuclear fusion, turning hydrogen into helium. And in a blinding flash of light, our sun was born.
Now, what's really wild about this is the sun's absolute dominance. When that nebula collapsed, the sun greedily gobbled up pretty much everything. It accounts for 99.8% of the entire mass of our solar system. That means literally everything else, all 8 planets, all those moons, millions of asteroids, and yeah, you and me, we are all made from just that tiny 0.2% sliver that was left over. Crazy, right?
So you're probably wondering, how did that leftover cosmic dust actually turn into a planet? Well, it comes down to a process called accretion. Now, I know accretion sounds like some heavy scientific jargon, but it's actually super simple. It's really just the process of tiny dust particles bumping into each other and sticking together, mostly thanks to static electricity and gravity. Just think about the sheer scale of this for a second. We're starting with microscopic dust particles in a spinning disk. They collide, they stick, and they form these little centimeter-sized clusters. Over millions of years, gravity pulls those clusters together and they grow into these massive rocks, kilometers wide, which we call planetesimals. Keep repeating that, and eventually they smash together to form huge, moon-sized bodies known as protoplanets. It's like building a planet brick by brick, starting from literal dust.
And the best part? We aren't just guessing here. We actually have tangible evidence. Astronomers with powerful telescopes can look out and watch this exact process happening right now in other nebulae. But even cooler than that, we have physical proof that falls right out of the sky, meteorites. Scientists look at these tiny pieces of space rock inside them called chondrules, and they've actually found radioactive elements like uranium in there that are 6 billion years old. Let that sink in. That means some of the elements right here on Earth were forged in a supernova before our solar system was even a thought.
So, keeping our journey anchored on this timeline, we've just covered the very beginning. But if we zoom in on that stretch right between 4.6 and 4 billion years ago, well, things take a pretty dramatic turn. As all those protoplanets were forming, the early solar system was basically a giant cosmic demolition derby. It was incredibly violent, and it leads us into one of the most terrifying eras of our planet's history.
Enter the Hadean Eon. And let me tell you, it's named after Hades, the Greek god of the underworld, for a very good reason. Earth was literally hell. For 600 million years, giant rocks, some of them hundreds of kilometers wide, were just constantly smashing into the young Earth. The sheer kinetic energy from all those collisions generated so much heat that it melted solid rock. The entire surface of the planet was just this endless, swirling sea of glowing red magma.
But, and this brilliantly illustrates one of the greatest cosmic ironies ever, this hellish bombardment was actually a lifesaver. See those water-rich comets and asteroids? That endless, violent barrage was essentially a giant planetary delivery system. They were bringing in high concentrations of water and ice crystals left over from the original solar nebula. So, ironically, the very things destroying the surface were also delivering the liquid water that's absolutely essential for life.
Okay, so as we finally exit the Hadean Eon and move into the Archean Eon, our giant ball of molten lava actually starts to organize itself. Driven entirely by the relentless force of gravity, Earth goes through a process called differentiation. It's kind of like if you drop sand into a glass of water. The heaviest stuff sinks to the bottom. So heavy elements like iron and nickel got pulled deep down into the center of the planet, while the lighter elements like oxygen and silicon floated right up to the surface.
That sinking of heavy metals is exactly what created our core, and it's actually split into two distinct layers. You've got the inner core, which is this massive ball of solid iron and nickel. It's under so much pressure down there that it can't even melt, despite being a scorching 6,000 degrees Celsius. But surrounding that is the liquid outer core, and here's why that matters. As that molten iron constantly churns around, it generates massive electrical currents. Those currents create Earth's magnetic field, our invisible shield that keeps our fragile atmosphere from getting completely blown away by deadly solar winds.
So thanks to differentiation, we get this beautifully structured planet. We've got the crust on top where we live, the deep core in the center, and a massive 3,000-kilometer thick mantle sandwiched in between. And every now and then, nature gives us a sneak peek at this deep architecture. When volcanoes erupt or heavy meteorites hit, the extreme pressure brings up incredibly rare, beautiful minerals, like olivine, right to the surface. It's literal physical proof of this complex hidden world operating right beneath our feet.
All right, so we've got a structured Earth, we've got a core, we've got some early water, but look up at the night sky and you really have to ask, how on earth did we get a moon? For a long time, this was a massive mystery. Scientists argued about whether it was just some wandering rock that got trapped by our gravity, or if it somehow formed right alongside us. But as it turns out, the truth is much, much more violent.
The currently accepted and, frankly, mind-blowing explanation is the giant impact hypothesis. About 4.5 billion years ago, when Earth was still basically a molten ball, it wasn't actually alone in its orbit. There was another Mars-sized protoplanet, which scientists named Theia, and it crossed our path. Theia violently slammed directly into the young Earth. It was a completely catastrophic collision. The metallic cores of both planets fused together into one, and a massive chunk of debris was just blasted out into orbit. Over time, gravity pulled all that floating debris together, and that formed our moon. Now, how could we possibly know that happened? Well, we can thank NASA's Apollo missions for that. When astronauts brought lunar soil samples back home, scientists made a totally startling discovery. The rocks and oxygen isotopes from the moon were a near-perfect match for the rocks right here on Earth. Plus, remember that massive iron core Earth has? It makes up about 30% of our planet's mass. But the moon's core? It's tiny, barely 1.6%. That huge contrast is basically smoking gun proof that the moon is made out of Earth's outer crust, blasted away during that horrific collision, leaving all the heavy iron behind here on Earth. So the crucial point here is that this catastrophic impact was quite possibly the luckiest day in our planet's history. Seriously, that collision knocked Earth slightly off its axis, which gave us our 23.5-degree rotational tilt. Without that tilt, there's no changing seasons, no summers, no winters. The climate would be way too extreme. On top of that, the gravity from our brand new moon created oceanic tides, which were absolutely essential for eventually coaxing early marine life out of the water and onto the land.
But to even have those oceans, the Earth first had to, cool off. We had massive volcanoes spewing out steam and toxic gases everywhere. Eventually, though, the planet did start to cool down. And as the atmosphere cooled, all that water vapor that got delivered by those asteroids started to condense, and it began to rain. And it rained, and it rained, literally for centuries. This massive downpour filled up the vast, deep oceans we know today. And those oceans immediately got to work like the ultimate planetary cleanup crew. They absorbed massive amounts of heat and toxic carbon dioxide, pulling it right out of the air and slowly making the atmosphere breathable.
When you look at all these factors together, it really hits you just how impossibly lucky we are. For a ball of boiling lava to become a life-sustaining oasis, we needed what scientists call the Goldilocks conditions. We needed to be exactly the right distance from the sun, not too hot, not too cold. We needed the perfect mass so our gravity could hold an atmosphere. We needed that spinning iron core to create a magnetic shield. We needed exactly the right amount of greenhouse gases from volcanoes to keep us warm, but not fry us completely like Venus. Every single dial on this cosmic machine had to be tuned to absolute perfection.
And that brings us to a really powerful thought straight from our source material. When you consider the sheer mathematical miracle of our existence, the chaos of supernovas, the extreme violence of planetary collisions, and millions of years of perfectly timed rainfalls, it really puts things in perspective. As the source says, everything that happened was exceptionally fantastic. It should be all of our duty to protect this wonderful planet.
We are sitting on the result of a 4.6 billion-year-old cosmic recipe. It is the absolute only home we have. Looking at the monumental, chaotic effort the universe went through just to build it, what are we going to do to preserve it? Thank you so much for joining me for this explainer. Keep wondering, keep learning, and I'll catch you next time.